Hello everyone and welcome to the Victoria Game Engine series. This is episode 9 and today we're going to be focusing on creating our platform-specific entry points. If you're wondering what I mean by platform-specific entry points, we can effectively explain what they are by looking at what we currently have set up in our main. So if you were following on from the last video, which would have been the OSLinux video where we set up our OS implementation for Linux, you will see that we have a little bit of a problem. And that is, of course, that all of our Linux classes and subsequent structs that we have created don't exist when we transfer back over to Windows. Now, of course, we could go and change these back to Display Manager Windows and OSWindows here as well, over and over and over again to avoid that. But of course, that's not very effective as a way of creating things. And we want to make sure that every version of our application can compile without having to manually change any of the code. So how do we do this? And the actual way that we do this is relatively simple, and it is through a platform-specific entry point. So platform-specific entry point may sound unusual, but all it is it's effectively a file within our platform folder that is the entry point for the application. It will be where our int main goes, and it will contain most of the functions that you see here. So for instance, the creation, the initialization, the running, the finalizing, and all of that will happen within our platform specific entry point. However, not all of the stuff that we currently have set up will. So for instance, the display manager, while we do want to have some control through our main, this will be moving into our OS implementations for the minute. We'll try to move it around and get it in a better spot eventually, but for now we will keep it here. So for the first implementation of our platform specific entry point, we are actually going to go to our Windows folder and we're going to go and create a new file and we're going to call it entry Windows. It doesn't need a header file because it's only going to import functions rather than exporting any functions. So in here, we're going to include our type defs, which seems a little counterintuitive at first, but this will become relevant later. We're then going to check if we're on Windows, because if we're not on Windows, we don't want this file to compile in a real regard, like so. And then we're going to want a couple of things, and those are we're going to want to include our OSWindows, because of course we're trying to initialize that through a single source. And we're also going to want to include our main as well, because we're going to be transforming that as well in a minute. And under here, there really isn't anything else we need to add other than our main function. So int main, and here we're going to specify the argument count and an array of cars for our arguments that we actually want to pass. Now, originally, we did set this to be void. However, at later points during the application, we will want to start doing some argument passing. So we'll want to change them from an array of strings into our own managed strings. And potentially, if we start using, say, UTF-16 or UTF-32 encoded strings, we'll need to start using something like wcar as well, which is a Windows-specific type, or it's a wide-car. It supports much more characters beyond the Latin alphabet, so we'll want to support that at some point, of course, however, not at the moment. So within this function, there's a couple of things that we're going to want to do. The first thing is we're going to want to initialize our OSWindows, and of course, because the OSWindows takes an argument for its H instance, we're just going to pass a null pointer. Technically, we could pass something such as a manually created H instance, so we don't have to go through the process of getting one. But for this case, I think it's just easier to do it this way. So we're going to leave a couple of lines blank here because there are a couple of things that we need to do first. However, one thing that we can do first is we can set up an error that we need to get of a value from another function a little bit later. And if this error is not caught as being its appropriate value, so if error is not equal to OK, at the moment it's set up in such a way that it'll always equal OK. But for this check, when we're a little bit later into the series, the function that will actually be going here will return values other than error. We're going to want to double check what kind of error we're dealing with. So if it's equivalent to error help, so the function that we're about to call, the function that we will call here is going to return a help message or a help string, then we're going to want to return exit success. Because whilst the function did return earlier than we were expecting, it does actually need to do a couple of things in the first place. And otherwise, we're going to want to return exit failure, because whatever has happened has failed. Some part of our setup has failed, and therefore we need to return. Then we're going to check again if error is equivalent to OK, and this will be a separate function that we will need to check. And in this case, we're going to call to our OS to run. And if this isn't the case, we're going to want to return exit failure. And then at the end, we're going to call to our OS to get the exit code. And whatever the exit code is set to is the value that we want to return. So at the moment, this is looking like a very bare bones OS setup, because nothing's actually happened. None of our functions really seem to make a lot of sense at the moment. And that's because there are a couple of changes that we need to make to our main. So before I get into the next bit, I'll explain very briefly why we're doing these changes. So the model that we're using here, again, is the same as Godot's model. That is where we start at a platform-specific entry point and then push everything that we want to deal with. So all of our actual setup of like core types that don't rely on the operating system, we want to push all of that creation into a central main that every different platform implementation can run off of, because they all want to act effectively the same, just with different implementations. And that's where the majority of our code will be handled, and that's where most of our iteration loops and that will happen within our code. Of course, the way we're going to be setting this up is going to be very similar to Godot's itself, and this is going to be back in our main file. We're going to be creating a class. We're going to call this a class main loop. However, for the sake of keeping it relatively simple, we're just going to name it class main. Again, this is simply because all of the functions that go through our main need to be called by every single application. And the only variables we're really going to have here are public ones. So we're going to have a static error setup, which takes the arguments and an array of cars. And I have been reminded that we need to include our error macros. We're then going to want another type called an error start, which doesn't take any arguments. We're going to want a static bool iteration, which you will be familiar with here. And we're going to take another static void finalize. And there are some other functions here that we'll add over time, but for the most part, these are the ones that we're going to need. We're also going to take this set should quit function, and we're going to move it into our main class because it's going to be very useful for setup, and we can get rid of the bool iteration from there. Now within here, we're going to start doing some gutting. So the first thing we're going to do is going to get rid of all of these things. Please note that the display manager is going to be moving as well. We'll be moving this to our OS class for the meantime. However, it will in the end up back in our main loop. So rather than being from set should quit, we're going to pass main set should quit. And the same thing for iteration here. The first thing we're going to do here is we're going to call to setup. So main setup. And the only thing that's going to happen in here for the most part is that we're going to call to our OS class to initialize. And if you'll remember, the includes that we have here really don't reflect that. So we're just going to include core os.h. And apparently I couldn't spell initialize. And then from here, we're just going to return OK. If you'll notice here, we do pass arguments here. So the main loop here, our main, will do some of our setup of getting our arguments sorted and passing all of those. But of course, that will come further down the line. Then next up, we're going to want to create our main start. And this function is also just going to return OK. The reasons behind these two here is that when we get a lot later into the series, we're going to want to start adding things to these two that will be slightly different on setup. So for instance, when we call setup, this takes all of our initial arguments that were passed and transforms them into things that the application can then use as different variables to understand what the application needs to do. And start is actually where we actually go and create most of what the user has specified. So whether that's setting up game scenes, setting up formats, importers, our rendering server needs to be set up, our editor needs to be created, because our editor, like Godot, is going to use the same model of the engine itself, uses the same tools as anyone would use to create their game. And likewise, we're going to have the same thing for our iteration loop, because that's just going to be the same as is, but we'll add things over time as we need to add things. And lastly, the one that we also need to add is our main finalize. And all this really needs to do is call to the display manager. So include core, not that one, core os display manager.h, and it just calls to display manager finalize. And otherwise, it would do a bunch of memory freeing on different things. Oh, one more change that we're going to make here is we're going to move the set should quit right up to the top here, just so that everything is in a slightly easier order, because this function is relatively simple and these ones get pretty long by the end of it. Now with all of these created and set up properly, we can go back to our entry function and start putting them where we need to put them. So instead of calling to OK here, we're going to call to main setup. I'm going to pass the argument count and the argvs. And so all this will now do is call to the OS to initialize and then return OK. So we really won't expect an error help message here just yet. And then here, we're going to call to main start. And this will start setting everything up. Then just before here, we're going to call again to main to finalize, so that everything that needs to be cleaned up can be cleaned up. And that is pretty much everything. So within here, we're now going to end up with a little error here. And we need to set this to main iteration, just so that we can get that out of the way. So here, just at the top, we're going to create a static variable, and we're going to call this a static display manager. I'm going to set it to null pointer initially. And down here, we're going to call display manager equals new display manager Windows, when you can spell it correctly, which it appears that I have not included. Okay, well, that needs to change to display manager Windows then. There we go. And that will create our display manager Windows. Another thing that we'll want to do is we'll actually want to go into display manager Windows itself. And something that I do ultimately change, that I should probably do here anyway, is that we're going to call create window here. The reason we call create window here is because eventually we're going to be passing the arguments of the Windows name, its width, its height, its position, its title, all of those things that will initially we'll want to set up here in our display manager Windows class, because there are certain things that the display manager will want to look at. So here it will pass Victoria engine window 100, 100, 1280, 720. And that will create our window as we want to. And also in this file, we do need to change this to the main set should quit. And for some reason, right. This needs to be a static void to avoid that error from appearing, because every member of main is static, so that any version of our operating system can call all of its functions. With all that said and done, we're just going to run a quick sanity check by first going to here and cleaning all the binaries, just in case anything has been messed up by us doing some of those changes. And then we're going to hit compile. And we should see that everything compiles just fine. You can then close out of that, hit F5, and if all things have gone as intended, this should run. And there we see that everything looks like it's working all good. Our window is open. It doesn't have anything in it, which is fine because we don't expect anything to be in it. And when we close it, everything closes just fine, which is great news for us because now we have set up our main here to work as intended. Now, normally I split these videos up into a focusing on Windows, then focusing on Linux. But since this is a relatively simple process, and to be honest, aside from name changes, there's not really anything that varies between Linux and Windows, I'm just going to go ahead and do the entry point for Linux as well. So we're going to go here, entry linux.c++. We're going to include our type defs again. We're going to check if we're on the Linux, of course, and if we're not, then we don't compile this, as we are used to doing by now. And in here, again, we're just going to include our OSLinux.h and include main. Then we're going to call to int main. And here we're going to set up an OSLinux OS. It doesn't need any arguments for its constructor, so we can leave that blank. Once an error, err equals main setup, passing our argument count and our variadic arguments. Again, if you're working on Linux, this should all be highlighted just fine for you. Of course, I'm working on Windows at the moment to get this video out in time, so this doesn't appear as it is for me, but it should appear, and syntax highlighting should work here. If it doesn't, please do let me know. And again, if we return if error is not equal to OK, we want to check if its error is equivalent to error help. In the case, return 0. Otherwise, return 1. And of course, if the main start is also equivalent to OK, then we call to os.run. Otherwise, we want to return that something has failed. So we'll return 1. Then we call to main finalize and return os.get exit code. And that should be the entirety of your main for Linux. And we'll do the same changes that we made to our OS again here. So we'll go in here and go down to the bottom here, set up our static display manager. Apparently I can't type today. And then display manager equals new display manager x11. And within our display manager, we are of course going to call to create window, passing Victoria engine window 100, 100, 1280, 720. And setting main set should quit here. And also double checking within here that main iteration is being called instead of just iteration, because of course we've changed it back to that. And again, if you are on Linux, you should be able to hit compile. Everything will change. Nothing for us has visibly changed, but fingers crossed that it has for you. And we hit run again, and you'll get your X11 window appearing where you want it. So with all of that out of the way, we're now pretty much done with creating our platform-specific entry points. And for the most part of this series, they aren't really going to get touched in any other way, since a lot of the stuff we are doing will simply funnel into either main or one of our specific OS implementations or whatever, and is very unlikely to be within our entry points. That being said, we could use stuff like Windows main if we really wanted to for Windows-based applications, if you wanted to be more compliant towards the Windows API, but you don't necessarily have to. And for the case of this video, I have decided not to go that way simply because of the nature of writing things in C++. I prefer to use more platform-agnostic ways rather than completely obeying the Windows API. But this is another pretty big step because now we can start moving on to the fun stuff, and the fun stuff is rendering. So in the next video, we will be going over a part of OpenGL rendering that I find isn't covered nearly as much as it should be. And that is the creation of a context without using a windowing library. So as many of you may have noticed from the rest of the series, we have tried to stay as close to the in-house APIs that every engine uses. As you will have noticed through the series, and as I have said throughout the series, we are trying to stay as dependency-free as possible to just show how the actual complexity of certain tasks can be done, but how they are ultimately still all doable. And one of the big things that a lot of people simply don't do when it comes to OpenGL rendering, which makes sense because often people simply want to create things using OpenGL rather than wonder about how we actually go through the process of setting up things like contexts. We will now go through that process manually, and you'll be able to see everything from how we query things, how they work on different devices, how different they're going to be, so on and so forth. But once we've gotten past the creation of a context, and it's a relatively few OpenGL functions before we actually get to the fun part of making something appear on our screen. So with that said, I really do hope that you enjoyed this video, and I'll see you guys in the next one, which, as I mentioned, will be a video on OpenGL context creation for the context of the Windows operating system. A bye.